Okay, this first video is an example of graphing piecewise functions. And really all it is two graphs or two functions being graphed on the same graph. The thing you really need to pay attention to are these constraints. These are your X constraints or domain constraints. And notice both of them are positive 2. And you don't have to do this, but I put like a little dotted line, a vertical dotted line on 2, and I call that a wall. Okay, because that's a stopping point for both of those equations. And what I'm going to do is I'm going to graph the first equation. I'm going to call it A, and I'm going to do all the work for graphing it down here. So this is f of x equals, and it's the first one, negative 1/2 x plus 4. And since our degree is 1, since the exponent we have is a 1, we know that this is linear, which means it's going to be a straight line. And I have to start, the first value that I should work with is 2. So I'm going to put that in here first. And then all the other values I use are going to be less than 2. So I'll go down to 1, 0, and negative 1. Right? So this first value, whether it's an equal to sign or not, should always be the first value that you have in your table. But I do know that when I graph it, the 2 is going to be an open circle. And that'll be on the wall. So I'm going to come down here, I'm going to plug these in. If I plug in 2 for x, I have negative 1/2 times 2 plus 4. So this is the 2. Negative 1/2 times 2 is negative 1 plus 4, which equals 3. So 2 gets a 3. Then I'm going to do the number 1 and plug that in for x. Y equals negative 1/2 times 1 plus 4. Negative 1/2 times 1 is going to be negative 1/2. And negative 1/2 plus 4 is 3.5. Or you could do decimal 3.5, that's fine. Okay, then I'm going to plug in 0. Negative 1/2 times 0 plus 4, and 1/2 times 0 is 0, and 0 and 4 is 4. And then finally I'm going to plug in negative 1. So I have negative 1/2 times negative 1 plus 4. Negative 1/2 times negative 1 is a positive 1/2 plus 4, and that's 4.5. Okay. So when I plot these on the wall, this first one is going to be the open circle. It's only one point that's going to have an open circle on it, and it has an open circle because there's no line underneath my inequality. So I'm going to go over 2 and up 3, and I'm going to draw a circle. Then I plot over 1 and up 3.5, over 0 and up 4, and negative 1 and up 4.5, and connect those, and this is a straight line. And notice this line only goes, to the left of my wall. It's not on the right side, it's everything from 2 to the left, because that's the way the arrow's pointing. But it's an open circle on the wall. Everything else is filled in. All right, then we're going to do the second equation. I'll call that B. I'll work that down here. And if you look at that, it's got the parentheses squared, so I know that this is a quadratic. And it's in vertex form, so I know my vertex. Whenever you have a quadratic, you do want to find your vertex, because that's going to be helpful when you graph it. And my vertex is going to be a positive 5, positive 4. Again, the first number in my table is going to be 2, but this time I'm going to pick values that are all greater than 2. So 2, 3, 4, and 5. So if I plug in 2, I'm going to make it a negative 1 in front of that parentheses, because that's what that negative means. Let's see, we're starting with 2 minus 5 squared plus 4. Remember your order of operations, always do it's in the parentheses first. So this is negative 1 times negative 3 squared plus 4. Negative 3, you're going to square before you multiply, because that's order of operations, exponents before you multiply. So this is negative 1 times 9 plus 4, which is negative 9 plus 4, which equals negative 5. So this is going to be 2, negative 5. And I know that this one is going to be a closed circle, because I do have the line underneath the inequality. Okay, I'm going to plug in 3. I have negative 1 times 3 minus 5 squared plus 4. 3 minus 5 is negative 2. Negative 2 squared is a positive 4, so it's negative 1 times positive 4 plus 4, which is negative 4 plus 4, which is 0. Oops. Okay, now I'm going to plug in, oops, getting this hard to see. Okay, now I'm going to plug in the 4. I have negative 1 times 4 minus 5 squared plus 4. Negative 1 times negative 1 squared plus 4. Negative 1 squared is a positive 1, so I have negative 1 times positive 1 plus 4. And negative 1 plus 4 is 3. So I'll come back up here and I'll put a 3 in here. And my vertex is 5, 4, so I know that 5 is going to be 5, 4. So my vertex is 5, 4. I'm going to go over 1, 2, 3, oh, that's 2, 3, 4, 5, and up 4. That's my vertex. My first point on the line is 2, negative 5, and that's going to be a closed circle because I have a line underneath the inequality. Then I go over 3 and up and down 0, over 4 and up 3. And this is a parabola, and I know that this is my vertex, so I know the points over here are going to mirror the points I've already plotted. So this is going to go up, around, whoops, having a hard time drawing today, around and down, and through there, and an arrow. There's no arrow over here because it stops at the wall. If I didn't have that wall, it would have continued that way, but I can't go anything to the left of x. Everything has to be to the right of 2. All right, so that's the first problem. I'm going to do one more for you. This time, I have my a value, my first equation here. I know that my constraints are both negative 3. So I'm going to do a vertical line at 1, 2, negative 3. Okay. And it's like think of it like a fortress, like a wall, like a barrier. They can't go past that wall. So that's why that's real important. And I'm always going to start with negative 3 for my first point. And then for A, they all are less than negative 3. So negative 4, negative 5, and negative 6. So I've got y equals 2 times x plus 5 squared minus 2. I'm going to start with negative 3. So I have 2 times negative 3 plus 5 squared minus 2, which gives me 2 times 2 squared minus 2. 2 squared is 4, so this is 2 times 4 minus 2. 2 times 4 is 8, and 8 minus 2 is 6. So negative 3 is a positive 6. Okay, then I'm going to do negative 4. So I have 2 times negative 4 plus 5 squared minus 2. Inside the parentheses first, negative 4 plus 5 is 1. 1 squared is 1, so 2 times 1 is 2, minus 2 is going to be 0, so negative 4 is at 0. Negative 5 plus 5 squared minus 2. Negative 5 plus 5 is 0, so 2 times 0 minus 2, 0 squared is 0, 2 times 2 is 0, 2 times 0 is 0, so it's going to be a negative 2. Okay, and then that last one, that last one is going to be negative 6. Well, actually, our vertex, remember, this is a quadratic. So our vertex is negative 5, negative 2. So I could have just used that for the vertex and not actually done the calculations, but you can see how it works. So if my vertex is negative 5, negative 2, and I have negative 3, 6, but that's an open circle, and I have negative 4, 0. Since this is my vertex, I know that this is going to mirror it on the other side. So negative 6 is also going to be 0. And then up here, it's going to be 6. And so, again, always have your vertex so that you know where it's curving when you've got a quadratic. And so that's just on that side. Okay, for B, we have another quadratic. And to get the x of my vertex, I'm going to use negative b over 2a because it's in standard form. My b is negative 2, so that's a positive 2 over 2 times my a, which is a negative 1. So it's 2 over negative 2, which is negative 1. So the x of my vertex is -1. My y is going to be -1 times -1 squared minus 2 times -1 plus 4. -1 squared is +1, so I have -1 times 1. -2 times -1 is a +2 and a +4. So I have 2 and 4 is 6, and this is going to be a -1, so that's going to be a 5. So my vertex is at -1, 5. My first point has to be -3 because that's my constraint. And I'm going to go points to the right of that. So I'm going to have -3, -2, -1, and 0. And I already know -1 is 5 because that's my vertex. So I just need to plug in these others. If I'm going to do -3 and plug that in, my equation is -x squared minus 2x plus 4. Make that -1x squared so you remember to multiply that after you do your square. So when I plug in -3, I have -1 times -3 squared minus 2 times -3 plus 4. -3 squared is a +9. So I have -9, -2 times -3 is a +6, plus 4. -9 plus 6 is -3, plus 4 is a +1. So up in this table, I'm going to put -3 has a +1. And then I have -2. So it's -1 times -2 squared minus 2 times -2 plus 4. That's -1 times +4. Always do your exponent first. Now we're going to go through and multiply. -1 times 4 is -4. -2 times -2 is a +4 plus 4. -4 plus 4 plus 4 is going to be 4. And since -1, 5 is my vertex, -1 and up 5 is my vertex, I know that I've got -3 up 1. It's a closed circle because of the inequality. So -3, 1. Then I have -2 and up 4. So I know on the other side the 0 is going to mirror that. That's also going to be 4. And then I'm going to have a value here. So this is going to go up. See if I can draw this one this time. Down and around like that. And then that's what your final graph looks like. So that's how you graph piecewise. You're basically taking two separate functions and putting them on one graph, but they both stop at a wall that they don't go past. I hope that helped.